if you already know if it's given to you, or if you can say that you have parallel lines, A is parallel to B, then you could say that, but you could also say, what is true about the alternate interior angles then? If you have parallel lines, what's true about those angles? They're congruent. If you know A is parallel to B, then what could you say about the alternate exterior angles? Congruent. If you know A is parallel to B, these are the names of the lines, by the way. What could you say about the corresponding angles? Corresponding angles are? Congruent. Because they're in the same spot in that group of four angles. And then what can you say about the consecutive interior angles if you have parallel lines? They're supplementary. So if you know parallel lines, then you can say that those things are true. But then we flip it for the converse. So all these same angle relationships, if you can show that those angle relationships are true, then you can say that you have parallel lines. So this is like, say you don't know for sure that they have parallel lines. It was not given to you. It did not state it in the proof. So you're going to have to show that that's true by showing one of these angle relationships. If you can show one of them, then you can say you have parallel lines. So if you can show that either alternate interior angles are congruent or alternate exterior is congruent, I'm writing the same ones as before. You already wrote these down. You can show that corresponding are congruent, or you can show that consecutive interior are supplementary. Then you can say that the lines are parallel. You should have your statements and reasons. We're doing a 2-column proof. We'll do more practice with this tomorrow, but today I want to get the notes done so you have them. We are given that A is parallel to B and that measure of angle 5 is 112. Let's mark that in the diagram. A is parallel to B, we can put those little notches. And 5 is 112, you could even write that in. That one is 112. So let's write it down in our proof now. A parallel to B, that's what the two lines mean. And measure of angle 5 equals 112 degrees. That is given to you in this proof. So we did the first part, we wrote down the givens, we marked what was given. So angle 5 and angle 6 are supplementary. You have to say that first, you can't jump straight to the equation. And like Aiden said, that's because of consecutive interior angles. The regular one, theorem. Consecutive interior angles are supplementary. And immediately following that, what do we say? There you go. Ugh. We're given that A is parallel to B, and that 7 is 93. Go ahead and mark that in your diagram as well. So A is parallel to B, we give it those 2 notches to help us remember. And we can even write that 7 is 93. Because that helps us visualize it. So we're trying to prove that measure of angle 9 is 87 degrees. Can you please discuss with that partner you just talked with before, why does it make sense that measure of angle 9 would be 87 degrees? So let's go ahead and say we have vertical angles. Since you're using measures and not congruence, I would keep that going. So measure of angle 7 equals the measure of angle 8 because of vertical angles. You can, if you just go straight to measures, I'll take it. It doesn't really matter to me. And then we can, how can we say that measure of angle 8 is 93 now? Substitution, so 93 equals the measure of angle 8 because we're substituting this, 93, for 7. So that's substitution. Brennan told us that 8 and 9 are supplementary. So the last part of this proof is going to look really similar to the one you just did. Angle 8 and angle 9 are supplementary. Bonnie, why is that again? Why can I say they're supplementary? Why they're supplementary, then we'll use a definition of supplementary to say 180. So consecutive interior angles theorem says they're supplementary. Now do the same thing you did in the last proof, right? We write an equation for 180. That 8 and 9 add to 180. This would be the definition of supplementary. And then can you please substitute and solve?
Plus measure angle 9, 180.
Yep. I just wrote subtraction. Substitution. Jacob, what's the last thing I should do? Okay. Proof. It's only 2 lines long. You are given that angle 1 is congruent to angle 2. I would mark that right away in my diagram, and I do that by marking it with the same type of arc. So if I do that, that shows that angle 1 is congruent to angle 2 because they're equal in measure. We're trying to prove that A is parallel to B. We know that 1 is congruent to 2. Cooper, what do you think? Can I say that the lines are parallel now?
Yeah.
How come?
Corresponding.
They're not corresponding. This is alternate interior angles. What, guys? Converse, because I am saying that the lines are parallel, so I'm going backwards. From angles to parallel lines, that's the converse. So write your statements and reasons again. Last one. Write what you're given. You know that 1 is congruent to 2. And that measure of angle 3 equals 88. And I would mark that right away in my diagram. 1 congruent to 2, give them the arcs to show they're congruent. And I would label angle 3 as 88. That way you can visualize it.
Well, angle 1 and angle 2 are parallel.
So because 1 and 2 are congruent and they're corresponding, I've got an angle relationship that I can prove, so I can say the lines are parallel. So corresponding, I'm just going to say corresponding converse. Now that you know the lines are parallel, you could go ahead and mark that in your diagram. So these are parallel. Now we can do what Olivia said and say those 2, 3, and 4 are supplementary, and we can use the equation to solve it like we've done for every other one on this paper. So angle 3 and angle 4 are supplementary. You can use the regular one for this because you know you have parallel lines now. So this is because of the consecutive interior angles theorem, not the converse. Can you please do the rest? If you're not sure what to do, then look at the other 2 proofs that are exactly like it. I'm going to finish the proof if you want to check your work.